Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, computing ratios of arc lengths to radii and describing the result. So it's going to be a very interpretation heavy assignment, but let's see what we got. So looking at this, we have circles C, F, and J, and a central angle of 30 degrees is shown on all of them. So all of these angles are 30 degrees. So how do we find the length of the arc given that piece of information? Okay, so what we're going to do, all right, we are going to first convert this into radians, right? So anytime I'm finding arc length, I need to have this in radians instead of degrees. So I'm going to change that 30 degrees to pi over 6. Then our formula is just the arc length, or S, is equal to r times theta, where theta is our angle. So for this AB here, my radius is 1, and my theta is pi over 6. So it's 1 times pi over 6, which is pi over 6 centimeters. Okay. For DE, it's still pi over 6 because they're all 30 degrees. But it's times 3 this time, so that would be pi over 2, or 3 pi over 6. And GH over here is 2 times pi over 6, which is 2 pi over 6, which reduces to pi over 3. Okay. And make sure you do write them this way, because they do ask for the exact answers in terms of pi, so that's where that's coming from. And that's going to help, because over here it's going to work out, because we're going to divide by a radius again, I guess. So if I have my length of AB divided by the radius, that's going to be pi over 6, right? So because divided by 1. Here, the length of DE is pi over 2 divided by the radius, so divided by 3. So when I divide by that, it just goes to the denominator, so I get pi over 6 again, 2 times 3. And here, it's pi over 3 divided by 2. So when I divide that in half, I get pi over 6 again. So what does that tell us? Does it tell us the length of the arc intercepted by a central angle is pi over 6 units more than the radius? And the ratio is increased by 1 unit as the length of the intercepted arcs increase? Oh, sorry, that's the second thing. It's a weird cutoff. The length of the arc intercepted by a central angle is pi over 6 units more than the radius. The ratios increase by 1 unit as the lengths of the intercepted arcs increase by pi over 6 units. The length of the arc intercepted by a central angle is proportional to the radius, or the ratios increase by pi over 6 units as the radii increase by 1 unit. Okay. So as we're looking through this, we need to look at really how they're phrasing this. So is it telling us there's something about pi over 6 more or increasing? It's really not. We're doing a division. That's a ratio, right? So that doesn't really work. So increasing more doesn't help. So it's really this proportional one. That's what we're setting up because we're doing that division. So what it tells us is the length of the arc intercepted by a central angle is proportional to the radius. That's why we keep getting the same thing off as long as it's the same angle.